Okay, so here I'm going to prove part one of the triangle midsegment theorem. And that simply says that the midsegment in a triangle is parallel to the third side. Now, what is the midsegment? The midsegment is the segment that joins the two midpoints of two of the sides of a triangle. So we find the midpoint of side AB and the midpoint of side AC. We label them DE, and the segment that connects DE or segment DE, what we want to prove is that it is parallel to segment BC. So in order to do that, we're going to extend segment DE, and we're going to construct segment EF congruent to segment DE. I use the compass here with radius at a radius DE with center at E. So this point right here will be point F. And EF is congruent to DE. So there it is. And I'm going to also construct the triangle by drawing segment FC. Now, we know that angle AED is congruent to angle CEF because they are vertical angles. And we also know that segment AE is congruent to segment EC because E is the midpoint of AC. And by construction, DE is congruent to segment EF. That means that by side, angle, side, um, triangle AED is congruent to triangle CEF. Now, because those triangles are congruent, we know that segment AD, that doesn't matter where we put it, segment AD is congruent to segment CF. Corresponding parts of congruent triangles are congruent. And we know that angle DAE is congruent to angle FCE. Again, the measurement doesn't matter. We just know that they are congruent. Now, looking at those two angles, which are congruent, we can take this to be two lines cut by that transversal, the transversal here being AC. And using the converse of the alternate interior angles theorem, which says when two lines are cut by a transversal and the alternate interior angles are congruent, the lines are parallel. So FC is parallel to AD and also parallel to AB. Now, segment DA is congruent to segment BD because D is the midpoint. And segment FC is congruent to DA, so it's also congruent to DB. So it turns out that segment BD and segment FC are congruent and parallel, which means that that shape is a parallelogram. Because it is a parallelogram, its opposite sides are parallel. That means DF is parallel to BC, and DE is part of BF, so BE is parallel to BC, which is what we wanted to prove. So the midsegment of a triangle is parallel to the third side. So part two of the triangle mid-segment theorem states that the midsegment is half the length of the third side, the side to which it's parallel. And so just continuing from the arguments from part one, we have a parallelogram BDFC. And what we want to prove is that segment DE, the mid segment, is half the length of segment BC. So we have the parallelogram, which means that segment DF is congruent to segment BC. But segment BF is made up of it's segment BE plus segment EF. And the way they were constructed, segment EF is congruent to segment DE. Therefore, two congruent parts of segment DF is the same as length as segment BC. Therefore, DE must be half the length of BC. And that's it. So the mid segment is parallel to the third sine and it's half its length. And that's it.